Okay, grade 12, I want to look at this November 2015 question on work, energy and power. There's a chainsaw chopping down a tree across the river, so if you hear a funny noise halfway through the video, it's the people across the river chopping down a tree. Okay, so the track for a motorbike race consists of a straight horizontal section that is 800 meters long. A participant, such as the one in the picture, rides at a certain average speed and completes the 800 meter course in 75 seconds. To maintain this speed, a constant driving force of 240 newtons acts on the motorbike. So he's going along here, there's 240 newtons, and that's giving him his speed. Calculate the average power developed by the motorbike for this motion. So we've got different ways of working out power. Power is the rate of doing work, so it is the amount of work divided by time, okay? But I would rather use this formula. The average power is equal to the force times the average velocity. Now the question hasn't given you a velocity, but it's told you it's a straight course and he goes 800 meters in 75 seconds. So you can work out his velocity because it's like speed equals distance over time. So you can get the velocity as distance over time, and these units are correct. So it's 800. Remember, I'm using divide for over, divided by 75. So his average velocity is going to be the total distance he traveled divided by the time. And so you end up with 10,6667. Okay, that'll be his average velocity. And then you just need to use this formula that P average equals FV average. So then the P is going to be there. Can you hear the chainsaw? If you can't hear the chainsaw, good. If you can, just ignore it. So now the power, the average power is going to be the force, which they tell you is 240 newtons, times by this average speed, 10,6667. So from this you will end up with an average power of 2,560 watts. If you put in 800 over 75 over here, you will get out exactly 2,560 watts. If you rounded it off, you'll get out 2,560 comma something or the other. So this is the average power. Now it says to you, another person practices on the same motorbike on a track with an incline. Starting from rest, the person rides a distance of 450 meters up the incline, which has a vertical height of 5 meters as shown. The total frictional force acting on the motorbike is 294 newtons. Well, that must be going down the hill. The combined mass of the rider and the motorbike is 300 kilograms, and the average driving force on the motorbike, which is like your F applied, as it moves up the incline is 350 newtons. Consider the motorbike and the rider as a single system. So they're just basically saying, think of this as one object. Draw a labeled free body diagram for the motorbike rider system on the incline. So I'm going to do a rough sketch of this. Okay, so the first thing we know is going to come in here is going to be FG. Now I can put these arrows in, but I can't label them. So there's FG. What else has he got? He has got friction. Okay, he has got friction acting down the slope. So please label these arrows. Then he's got F applied acting up the slope. Okay, and then we have the normal, which you will draw in with your set square at 90 degrees to the slope. So I've got 4 marks, I've got 4 arrows. His FG, little f for friction, big FA for F applied, and there is his normal force acting at right angles to the slope. State the work energy theorem in words. There we go. Use energy principles to calculate the speed of the motorbike at the end of the 450 meter ride. So now we know that he's traveled 450 meters, and we know that there are non-conservative forces at work here because it's told you that there's a driving force and there is friction. So friction is a non-conservative force. So if I were to use a formula here, I would come up and I would take this one, that the non-conservative work, okay, is equal to the change in the kinetic energy plus the change in the potential energy. So now we need to know what is doing non-conservative work. And there are two things doing non-conservative work. There's the applied force, the driving force, and there is the frictional force. So if we take up the slope to be positive, okay, so if we say up the slope is positive, then let's have a look here. My non-conservative work is going to be this applied force, because remember now I'm going to be using this formula here as well. Yeah, the work, okay, look here, the work is equal to the force times the displacement times the cos of the angle. So I'm going to be substituting in for this non-conservative work with this formula here. So the first thing I'm going to look at is this applied force. So I've got a 350 Newton force. Okay, I've got a 300, where's my pen? Where did this go? This is so frustrating when this does this. Okay, so I've got a 350 Newton force. It is going up the slope for a total distance of, as you can see in the question, 450 meters. So it's force times the displacement times the cos of theta here. Okay, so I'm substituting in here. So if up the slope is positive, this is the cos of 0. Okay, which is the cos of 0 is 1. Now I'm going to add in my other non-conservative force, which is the friction here. Okay, and can you see here we've got the friction there, 294 newtons. So now this is going to be 294. It's also acting on the whole slope, which is 450 meters, so that's it's being displaced that much, times by the cos of, which way is friction acting? In the opposite direction. So it is times by the cos of 180. So that will become a negative number. And now this is equal to the change in the kinetic energy. So remember, we're going to use these two formulas, the EP and the EK. Okay, so here I'm going to substitute in here a half. I can't remember what's the code for a half, so I'm going to put in 0,5 for a half. Okay, and then it's going to be M. Remember that the system is 300 kilograms, a half M. And then it is the change. Look at the formula, it's delta EK, so it's going to be the final velocity. So it's VF squared, okay, minus VI squared. What was VI squared? VI was 0, okay, and then the squared is just optional on there. Okay, so now I've got over here, I've got my non-conservative forces, I've got my change in kinetic energy plus my change in potential energy, which will be mgh final minus mgh initial. So my m is 300, my g is 9.8, and now this is going to be the height final. And if this is the 0 reference, my final height will be 5 meters. My initial height is going to be 0 meters. So now we've set up this whole equation. So then you end up with, I don't know, you end up with 157,500. And now this becomes minus because it's the cos of 180, 132300. So those are my two non-conservative forces. A half of 300 is 150, so this will be 150 VF squared minus, what is that value? 300 times 9.8 times 5. You end up with 14,700. So now if you have a look in this equation here, the only thing that you don't know is the final velocity, which is what you're trying to calculate. So by the power invested in you by algebra, you will end up with your final velocity being 8,37 meters per second, like that. Okay, so you have to go and figure out what are my non-conservative forces, what is my change in kinetic energy, what is my change in potential energy, and you substitute your forces into this work formula. So the non-conservative work is based on the force times the distance moved in the direction of the force, and that's how you end up with your answer.